Okay, guys, in this lesson, we're going to learn about linear and nonlinear functions and how to identify if a graph, equation, or a function table is linear or nonlinear. So let's talk about what a linear function is. Here are 3 examples of linear functions. Notice that they are straight lines, and we have our first example has a positive slope. We are going uphill in this first example. This is a linear function. It passes the vertical line test. If I were to put a straight vertical line, it would only intersect one place. Our second example is linear and it has a negative slope. It is going downhill and it passes the vertical line test. And then lastly, we have the horizontal line of y equals -2. All my y values are some number, comma 2. And this is also a function. It passes the vertical line test. So functions that form straight lines are called linear functions. And all lines, and like these 3 examples, are functions except the vertical line. Remember, the vertical line does not pass the vertical line test. So we have our equations. Here's the graph and here's the equation that goes with it. These are all linear functions. So notice that the exponents on all of my variables is an understood 1. This is what makes an equation linear. So make sure you jot that in your notes. All linear functions written as equations has an understood positive 1 exponent. Here are some graphs of functions that are nonlinear. They do not have a straight line. They have curves. They do pass the vertical line test in our functions, but they're nonlinear functions. We have a quadratic, we have a cubic, and we have another quadratic. Here are the equations to these nonlinear graphs. Notice the exponent is not an understood 1 or a 1. So any equation that has an exponent on either of the variables that is not 1 is nonlinear. So you will be asked to identify a set of equations and categorize them as linear and nonlinear. What makes an equation linear is it has an exponent of 1 on all the variables. What makes an equation nonlinear is when the exponent on the variables is not a 1. It's a 2, 3, 4, and so forth. So now I'm going to show you how to use the Desmos calculator, and we're going to do a few of these examples, and that way you can see, using the graphing tool, if our equation is linear or nonlinear. So desmos.com. So let's take a look at this example. Y equals, so we're always going to have y equals. And I'm going to toggle back to the equation. And it's 4x squared minus 5. Now, according to what we just studied, this should be nonlinear. $4x, I'm going to use the caret key, which is above the 6, square, and then arrow out. And you can see, and you can scroll this down, that this is not a line. This is nonlinear. Now, let's delete that and try a new one. Let's do y equals, let's do x, and then our caret, and put a 3, and then say minus 2. So let's scroll up so we can see the entire graph. You can see this is not a line. Now, let's take out the exponent of 3, and now we have an understood exponent of 1, and you can see that it's a line. I could put a negative and it's going to slope down. I could change the coefficient to like 1/2 and my slope is not as steep. We can put a 4 and make it very steep. We can say -2 and shift it down some. Let's just say -3 and then put a caret. Oh, well, we need a variable x and then use our caret and put 4 and you can see it's not a line. But if we put the 1, the understood 1, it makes a line. We can say y equals 2 and we can see that it is the horizontal line. It is linear and it's a function. We could say x equals 5 and we can see it's the vertical line. We could use it's going to make the table, but that's okay. Another thing is, so we see that this is linear, but it is not a function. So to be linear, my exponent on my x and y has to be a 1. Okay, let's continue. So if you don't have a graphing tool, such as the Desmos calculator we just looked at, you're going to make a function table and use 5 input values. And we're going to go in chronological order. My inputs for x is going to be -2, -1, 0, 1, and 2. You can choose any points you want, but these are a good selection of values because we can see what the graph looks on the left side of the y-axis. We can see what it looks like when x is 0, which would be the y-intercept. And we can see a couple of points on the right side of the y-axis. So let's do one here, and we're asking, is this function linear or not? So we are going to create a function table. And we're going to plug in -2, -1, 0, 1, and 2. So we're going to get the output by plugging in these values. So I have 2 times, I'm going to plug in -2 for x, y equals -4 minus 3. We have y equals -7. So there is one ordered pair. So let's plot that, -2, -7 right here. Then we're going to plug in -1 for x. So 2 times we plug in our x value, we do order of operations, and we get a y value of -5. So let's plug -1, comma, -5. And again, this should create a line. These should line up. Then when I put in y equals 2 times 0, I get 0 minus 3, and my output is -3. So 0, comma, -3 is here, and I can see these are lining up. Now we're going to put in a 1, so y equals 2 times 1 minus 3. That gives me y equals 2 minus 3, and the y value is -1. So we have 1, comma, -1. And then we're going to put in y equals 2. We're going to put in 2 for x. We get y is equal to 4 minus 3, and y equals 1. So 2, comma, 1. And we can see what the graph looks like. So we can always create a function table and then graph those 5 points and see if it's linear or nonlinear. And we could tell that this equation was going to be linear because our exponents on our variables was a 1. Okay, let's try this one. Okay, so here's the function table. I think that was missing on the earlier slide. So we're going to plug in, using parentheses, -2 for x. And now we're going to square -2, which is a +4. And my y value is 3. Now let's plug in a -1, using parentheses to plug in. I get +1. So my y value is 0. We're going to plug in 0 for x. We're going to get 0 minus 1, and my y value is -1. We're going to plug in +1, and we get 1 squared is 1 minus 1, and y is 0. We're going to plug in 2. for x. We're going to square, and we get 4 minus 1, which is going to be 3. Now let's graph these. We have negative 2, 3. We have negative 1, 0. We have 0, negative 1. We have 1, 0. And we have 2, 3. And we can see this makes a parabola. Parabolas are like a U-shaped, and they have an exponent of 2 on the x. So this is non-linear, but it is a function. Okay, let's try another one. So we're going to plug in. We have a negative from the equation. So be very careful. Some folks get this wrong because they get in too big of a hurry. We're going to cube negative 2. So it's negative 2 times negative 2 times negative 2, which gives me a negative 8. And then negative 8 times this understood negative 1 is positive 8, and we get an outcome of 6. Then we're going to plug in, we have a negative from the equation. We're going to plug in negative 1 for x. We're going to cube negative 1. Negative 1 times negative 1 times negative 1 is negative 1. And we have this understood negative on the outside. That gives us 1 minus 2. And my y value is negative 1. Now we're going to plug in 0. I love plugging in 0 because it just totally wipes out that term. So I'm going to get negative times 0, which is going to be negative 2. Now we're going to be very careful, and we're going to plug in a positive 1. When we cube positive 1, we get positive 1, but this we have a negative here. So we get negative 1 minus 2, which gives us negative 3. And then our last one, y equals negative, and then in parentheses, we have positive 2 cubed minus 2. When we cube 2, we get 8, so we have y equals the negative times 8 minus 2. That gives me negative 8 minus 2, which is negative 10. So let's plot these. So we have negative 2, 6. We have negative 1, negative 1. We have 0, negative 2. We have 1, negative 3. You can see these are not lining up. And then we have 2, comma, and then a point way down here. So this is a cubic, and it kind of curves around like this. This is a function, and it is non-linear. Okay, so that is how we do using a function table. Now, I do want to go over this. So it says my y equals negative 4. So no matter what x is, the y values are negative 4, because that's what the equation says. So I'm going to plot these. So I'm going to say negative 2, negative 4, negative 1, negative 4, 0, comma, negative 4, 1, comma, negative 4, and 2, comma, negative 4. So we can see this is that horizontal line, not very horizontal with my drawing, but you get the point. This is a function, and it is linear. Okay, now let's take a look at this one. Notice my input values are not negative 2, negative 1, 0, 1, 2, because the equation says x has to be negative 4. The y's, no matter what y is, x is negative 4. So I'm going to go and plot these points. So we have negative 4, negative 2, negative 4, negative 1, negative 4, 0, negative 4, positive 1, and negative 4, 2. This creates that vertical line that does not pass the vertical line test. This is linear and not a function. Okay, so here's a summary. All equations with an exponent of 1, where our variables have an exponent of 1, are lines. All these graphs are a function except the vertical line. These equations look like x equals some number such as 8. Equations with exponents on the variables that are not 1 are nonlinear graphs. So what about a nonlinear graph that's not a function? We've not talked about that. So this is what that looks like. So just write this in your notes. When your square or your cube is on the y, the normal parabola or cubic is going to be turned sideways, making it nonlinear because it's not a line, and not a function because it doesn't pass the vertical line test. So if we had y to the third equals 3x plus 1, that would be our cubic turned like this. It would be a function, but nonlinear. So just know what these equations look like. So let's pause the video and you jot down 1 through 7 and tell me if it's linear, nonlinear, and function, not function. Okay, guys, we know this is non-linear because it doesn't have an exponent of 1 here, but it is a function, and I just need to understand that when you have an exponent of 2 on the x, you have a parabola. This is quadratic. The 2 says it's quadratic, and it makes a U shape, and it is a function. Here we have a line, and it's actually sloping down because we have a negative coefficient here. So this is, let me say, this is a function. This one is linear and a function. Number 3, this is linear. We have 1 exponent, and it is a function. Number 4, this is the vertical line. It's linear, but not a function. Number 5 is the horizontal line. This is linear and a function. Number 6 is the cubic. It looks like this, sort of. So this is non-linear, but it is a function. So make sure you know, let me redraw that. It looks something like this. This is a cubic. Okay, and then this one is our sideways parabola. So this is non-linear and not a function. So just be familiar with these type of equations. But remember, you can always graph them. I hope this helps.